Hello viewers, in this tutorial we will try to know how to detect outliers in R. There are several ways to detect outliers in R, but basically there are some commonly used method, that is box plot, Cook's distance and z-score. These are commonly used in detecting outliers. So in this tutorial I will show you how to apply this method in R, and we will use the life cycle savings data here to detect the outlier where we apply this method. Okay, so let us load the data first. So data life cycle savings, life cycle, so it is suggesting us the data. So life cycle savings, hit enter. Okay, so if you run this code, okay, the data is loaded. So the data contains 50 observations and 5 variables. So let us view the data first. View data and run it. So this is our data: population 15, population 75, DPI, DDPI, and SR. So these are our variables and these are the country names. So let us apply the first method, that is box plot. So we wish to create the box plot for SR variable. So we write the command box plot and write our data first and $sign to select variables SR. So run it. So this is our box plot, which preliminary indicating that the data do not contain any outlier, but we will check it again using the next command, box plot dot stats, and write our data $SR, and also mention here $out and run it. So it's showing that numeric 0. That means this dataset, or particularly this variable, does not contain any outlier here. So let us check with another variable. So if we change the variable SR and replace it by population 15 and run it again, so we see the box plot, and it also shows that it seems that this variable does not contain any outlier. So again check it here. So write population 15 and run it. Okay, this also shows that there is no outlier. So let us check it with another method like Cook's distance and check whether the method find any outlier or not. So basically, what is Cook's distance? Cook's distance is a measure of the influence of data point on the estimated regression coefficient. A data point with a high Cook's distance value may be an outlier or have a large influence on the regression coefficients. So let us calculate the Cook's distance. So we will calculate the Cook's distance by simply fitting a regression model. So let us fit a regression model. So we will fit the regression model named LR and write the LM function for linear regression model, and put our dependent variable as SR and our independent variable, that is of 15 plus of 75 plus DPI plus DDPI, and our data is data. So run this model. Okay, the model is fitted. Now let us check the summary of the model. So summary and LR, our model name, and run it. So this is the summary. The summary shows the residuals summary statistics, that is mean, first quartile, median, third quartile, and maximum. And the coefficients, there is y-intercept term, and these are the slopes of the regression model, that is beta 1, beta 2, beta 3, and beta 4. These are the estimates or coefficients of these parameters, and these are the standard error. And obviously that is t value, which is the respective t values of these parameters, and there is probability values. Okay, so we can also calculate the ANOVA, analysis of variance, from this model, by writing the simple command ANOVA and write ALR and run it. Okay, so this is our ANOVA table analysis of variance. So that is not our motto. We want to calculate the Cook's distance, so we will write the command Cook's distance, CWOKS Cook's distance, and write our model ALR. Okay, so we will just calculate the Cook's distance from this model. So we run code. Okay, now check the distances by running the code again. COKS Cooks SD, what we assigned here. So run it. So these are the distances. So if we write, so from these distances we cannot decide which is our outlier. So what we will write? We will write which function to identify which observations is greater than 1. We will consider the observation which is greater than 1 as outlier. So we write Cook's outlier and write which function, then our Cook's distance greater than 1 and run it. Okay, again run this code, Cook's outlier, and run it. So this also indicating that our dataset do not have any outlier because named integers showed 0, and you can see that the distances shown here are below 1. So I think this measures gives us the accurate result. So this dataset does not contain any outlier. So if our dataset have any outlier, then we can show it in a plot, but since our dataset does not contain an outlier, so we cannot show it in our. So let us apply another technique, that is z-score. So what is basically z-score? The z-score is a measure of how many standard deviation an observation is away from the mean. Observations with z-score greater than a certain threshold, example Gracia 2 or 3, are considered potential outliers. So let us apply this technique to calculate and identify potential outliers using the z-score. So what we will write? We write the z-score. So our first work is to scale the data set. So we will not scale the whole data set, we will scale a specific variable like SR. So scale our data $SR. So we will scale this variable. So run it. Okay, our variable is scaled. Now we will see if our absolute z-score is greater than 2 or not, because it has a threshold that greater than 2 or 3 are considered potential outliers. So let us check. So z outlier. So we will write the command which, then write our absolute value, then z-score. Z-score which is greater than 2. Okay, so run it and again run the command zout and run it. Okay, so using this method we found two outliers here, 7 and 23. Okay, so 7 and 23, these two are the outliers. So in this example we calculate the z-scores for the SR variable in life cycle savings data and identify two potential outliers with z-score greater than 2. So in this tutorial we applied three methods. One is box plot, the second is Cook's distance, and the third is z-score. So applying the first two methods, that means box plot and Cook's distance, we didn't find any outliers, but the z-scores identified two outliers. These are two potential outliers. So using these three methods, you can calculate the potential outliers from your datasets in R. So thanks for watching.